Hi, Algebra 1B students. We are in Lesson 5, the final lesson of the Unit 1 project. There are 8 questions here, so we do need to get going, but the good news is for us that we have done a lot of these problems already, so they're just kind of asking it in a different way. So this Lesson 5 is talking about end behavior of parabolas, and it's got some really good information for us. Let's go ahead and read through the directions and then we'll move on to question 1. The key features of a parabola can be used to interpret the equation or graph mathematically as well as contextually. Use the graph you described in lesson 3 and identify its key features. Then interpret those features and describe what they mean. Okay, so for question 1, all they're asking us to do, and we kind of already did this for lesson 4, they're just asking us to replace the h and the t with y and x. So if you'll recall, that equation that we came up with in lesson 3 was h equals negative 16t squared plus 20t plus 6, okay? And all they want us to do is now rewrite that as our y value, because that's what we're typically using x and y to graph, but we have to understand what that y value means. So that's why we used h to begin with. So that y value was representing our height, where our x value was representing our time. So now we're replacing t with x. So maybe you did or maybe you did not notice that in lesson 4 they kind of already did that for us, but that's what you would write here. It would look just like this. Okay. Next question. What are the coordinates for the y-intercept of the parabola? So we kind of talked about this pretty extensively previously. The fact that Janelle let go of the ball at time 0, and then that time 0 was our initial height of 6. Okay, so the parabola is crossing the the y-axis at 6, or our time 0 has an initial height of 6. And if you need a kind of refresher for what that truly looked like, you can see it here on the graph. And I'm going to go ahead and go up to my equations and get rid of this one. Okay, so you can see that we're crossing that y-axis here at about 6. Really, it's exactly 6. Okay, so hopefully that clarifies that. So the coordinates then would be x is 0 and y is 6, and you would write those coordinates inside a set of parentheses like 0, 6. And I think they have a space there, so maybe they did 0, space 6. Just be careful how you enter those. And then if you have questions, you know, if the computer marks you wrong on that, just notify me. Not a big deal. Okay. Next question. How many x-intercepts does the parabola have? In other words, how many times does it cross the x-axis? Well, we already, we kind of determined that from the discriminant. We figured out that it was going to cross twice from the discriminant. But let's just check it again. And yeah, we can see that that parabola goes right through that x-axis 2 times. Okay, so there are 2 coordinates for x-intercepts on this parabola. All right, so 2. And let's see, what are the x-coordinates of the x-intercept? So at what values does it cross the x-axis? Okay, so this is basically those solutions, and we did this. Back in lesson 3, we calculated at what values we went through the x-axis, but let's just do it again. Okay, so we're going to solve for 0. We're going to say negative 16 x squared plus 20x plus 6, where ax squared plus bx plus c, and let's set that equal to 0, equals 0 is my standard form. So a equals negative 16, b equals 20, and c equals 6. My quadratic equation is minus b plus or minus the square root of b squared minus 4ac all over 2a is equal to x. So I'm going to plug those values in. Minus 20 plus or minus the square root of 20 squared minus 4 times negative 16 times 6 all over 2 times negative 16. Okay, so 4 times 16 times 6 is 384, and I'm going to add that to 20 squared, which is 400. So I've got negative 20 plus or minus the square root of 400 plus 384, so 784, all over a negative 32, which is 2 times negative 16. So the square root of 784 is fortunately a nice, easy number. So I have negative 20 plus or minus 28 all over negative 32. Okay, so one x value is going to be when I add, the other will be when I subtract. So x equals negative 20 plus 28 over negative 32. So this becomes a positive 8 over a negative 32, which is a negative 0.25. Okay, so that's one x value. The other one will be a negative 20 minus 28 over negative 32, which will be a negative 48 over negative 32. And when you put that in your calculator, you'll see that that is a positive 1.5. So the two roots of that parabola are at negative 0.25 and a positive 1.5. This is actually the one that we kind of found in lesson 3. Okay, let's keep going. What is the end behavior of this parabola? Hopefully we've seen it a lot of times so that we can see this should be kind of a gimme. It opens down. Okay, it's kind of a frowny face parabola. All right, what is the equation for the axis of symmetry of the parabola? And the axis of symmetry, if you'll remember from this lesson, is the line. So our parabola is going to look something like this. And then we talked about the fact that they were symmetrical. Okay. The equation for the axis of symmetry is x equals whatever value that is. Okay. That is a line that that we're coming up with the equation for, that the parabola could fold in half over and it would be perfectly symmetrical. So we have determined that the x value for the axis of symmetry is negative b over 2a. All right. Remember, we've got negative 16x squared plus 20x plus 6, where this is a, b, and c. Okay, so that's my standard form. Well, negative b equals a negative 20 over 2 times negative 16. So this is negative 20 over negative 32, which if you plug that in your calculator, you'll get a positive 0.625. So that means at x equals 0.265, my parabola is perfectly symmetrical. It's also the x value of my vertex, the highest point or lowest point, if you're dealing with a parabola the other direction, that the projectile is going to reach. Okay, so for this one though, all you need is x equal 0.625. Okay, we're getting there. So now that we know that x value, we can easily calculate the y value. So we are going to find, this is one thing we haven't done yet, so we're going to find that max height of this parabola. And we know from this graph here that it should be right around 12.25, but let's just verify that with some actual math. All right, so we're going to say that y equals negative 16x squared plus 20x plus 6, and I am going to solve this for when x equals 0.625. So y equal negative 16 times 0.625 squared plus 20 times 0.625 plus 6. So 0.625 squared is 0.3906 times a negative 16. Okay, gives me a negative 6.25. Okay, 20 times 0.625 is 12.5. And I've still got to add 6. Okay, so, and that exactly equals what we saw on that graph of y equal 12.25. So our ordered pair, or our coordinates, are 0.625, comma, space 12.25. That is the point where we reach the vertex, or the very top of the parabola. Okay, last but not least question for this unit. What does the vertex represent in context of the basketball shot? Explain what happens to the ball at the vertex and whether the point is a minimum or a maximum point for the parabola. So hopefully you realize that it is a maximum. It's the maximum height that the ball is traveling along this parabolic arc. And the vertex is the point where it changes direction. So up until the vertex, the ball is going up, and after the vertex, the ball is going to head back down. Okay, so 12.25 is the highest point that the ball reaches, and it reaches that point at 0.625 seconds. Okay, so that is the last question for this entire unit. Once you finish with the Lesson 5 project, you can submit it and it will come to me and I will grade it. I am very much looking forward to seeing how these videos help you guys through these projects. And if you have any feedback for me, I would love to receive it. So thank you so much for your time and have a great rest of your day.